Hello everyone, good morning. Hope everybody is doing well today. Just going to wait for a couple more people to arrive. Okay, so welcome to another Spring Showcase. Today marks Showcase 34 for Spring, where we'll hear from IXOM all about how their innovative MIEX solution has supported Yorkshire Water in improving drinking water quality and throughput at sites that previously faced challenges in these areas. For those of you who might not know, Spring is the Innovation Centre of Excellence for the UK and Ireland water sector, and we're here to create centralised intelligence around what already exists in the water innovation space. Our goal is to enable collaboration, remove duplication, and accelerate innovation within the water sector. So before we begin, I just wanted to touch a little bit on why we do these deep dive knowledge sharing sessions like today. So globally at the moment, the water sector is under significant scrutiny and we really need to accelerate problem solving. And knowledge sharing is one of the ways which we can do that. So last year we partnered with the economic regulator for England and Wales to build a view of what best practice knowledge sharing looks like. We brought together senior leaders and innovation managers to design a vision for knowledge sharing. What is it we're actually trying to achieve? And ultimately the answer was that we want to unlock faster adoption by creating a world-class knowledge sharing culture. So we then built out the 6 best practice principles, which are: number 1, learn from what already exists before committing to innovation projects. So Spring is building a centralised source for what already exists so that you can come and check in with us and learn from what is already out there before making an investment on a new project. Number 2 is target innovation insights to the right audience to meet our objectives. So we really want to make sure that the right people are on our calls listening to the lessons. So for today, do we have our kind of data scientists? Do we have our water quality specialists? And so on and so forth. And we really want to make sure we have decision makers involved as well that can actually take this away and say, we are going to use this knowledge in our organisation. So if you know any decision makers at your organisation, please do encourage them to come along to our Spring Showcases to lead to faster adoption. Number 4 is sector knowledge is open. I missed one. Number 3 is insights are regularly shared through multiple channels from day 1 of the project. So historically, knowledge share happens at the end of the project, and we really want to start moving towards a model where we share from day 1 all the way through the project. Now on to number 4, sector knowledge is open and centralised. So we want to make sure that we are all being open and honest when it comes to knowledge from innovation projects. And we want to make sure it's all in one place because fragmented knowledge makes it very difficult to engage with and learn from. Number 5 is insights from both innovation successes and failures are shared. As we know, the lessons learned from failures are just as important as the lessons of success. And we'll hear about some of these from our presenters today. Number 6, finally, is people are empowered to receive and embed lessons from external sources. So Spring and the presenters on this call can all share knowledge, but we really want to make sure that the receivers of the knowledge have the resources and the capacity required to actually make that change and feel empowered to do so within their organisation. In terms of what will be shared, I would encourage you to take a look at the Water Innovation Strategy 2050. For anyone who hasn't seen that document, it lives on our website and it outlines 7 main themes with challenges sitting under those themes that we're currently trying to tackle in the sector. My colleague will pop a link to that in the chat along with the Spring platform link too. We also hosted a webinar about the best practice principles on the 21st of November, which is also on our platform. So you can find it under the knowledge section along with previous showcases and case studies if you would like to watch that webinar back at all. So back to today, I'd just like to give a warm welcome to all the audience members who are joining us live. We are joined by water companies, supply chain and academia across the UK and Ireland, and plenty of overseas colleagues too. So welcome to the call and thank you for taking the time out of your day to join us. We'll link a poll at the end of the showcase to find out how interesting you found the information and whether you actually plan to take action on the knowledge share today, whether that means go away to fully embed it to start a new project based off of the information you received today, or whether it means using today's session to inform a project that you're already working on. Just let us know. It's really great to know that we are actually making an impact with these, and any feedback you give us helps us shape these to make sure that you find them really valuable. So on to today's session, I'm just going to run through the agenda, introduce our speakers, and then touch a little bit more on why we knowledge share in a bit of a deeper fashion before handing over to the team. So we'll start with an introduction to knowledge sharing for myself, as I say, and then it will be followed by context behind the actual problem at Langsett Water Treatment Works and across Yorkshire Water that made kind of Yorkshire Water reach out to IXOM in the first place. We'll then go into an overview of the MIEX technology and take a detailed look at the solution and the benefits seen before heading into a short break. After the break, we'll do a deeper dive into the learnings and challenges that the team faced during the project, and then we'll finish up with the usual Q&A session. So if you have any questions or queries throughout the presentation, just pop them into the chat, and we will make sure to ask the presenters those at the end. So speakers-wise, we'll be hearing from, we're really excited to have Neil Whitehead, Senior Asset Sponsor at Yorkshire Water, joining us today. And then we have Neil Woodlands, Business Development Manager, and Sasha Golubovic, Business Manager at IXOM. So, why knowledge share? As I touched on before, the water industry is under public scrutiny at the moment, and there are many who just simply aren't aware of the fantastic innovation projects taking place across water companies, not just in the UK and Ireland, but globally too. And that's because while great work is being done, it is historically being completed in individual water companies, in sort of mini silos, with little to no sharing taking place about the really exciting learnings and outcomes. So not only does this lead to a decreased reputation amongst customers because they simply aren't aware of the strides being made, but it has led to projects being duplicated an average of 4 times across the sector in the UK. And that's a huge amount of cost, resource and time that ends up allocated to the wrong places. So that's why Spring are really striving to centralise intelligence and awareness of innovation, so that we can start moving towards a sector that openly shares successes, challenges and failures too, so that a project only needs to happen once to determine if a solution will work or not. Sharing these outcomes and working collaboratively will only make the sector stronger and will put us in the position to solve priority challenges that we are collectively facing much quicker and reach adoption goals at a much faster pace. The more we share, the quicker we'll get there, bringing considerable benefits to individual organisations, customers and the environment alike. And so with that, I'll now hand over to Neil Whitehead to talk us through the context behind the project today. Thank you, Neil.
Good morning, everybody, and thank you, Leah, for the introduction. Please may I just reiterate what Leah's said about knowledge and sharing. I'm fortunate enough, some would say, to have been in the industry 30 years now, having spent time at Thames Water and United Utilities. And one of the benefits that I've had in my career is being involved in such events like today. More back in the days, we used to meet up physically, and not only learning about new stuff, but making a network of contacts is so important, particularly for our younger scientists and engineers. That's how we've got to where we are today, and I would encourage as many of you as possible to explore and expand your careers in a similar way. Right. Okay, so we're going to talk about, or I'm not going to talk about particularly IXOM. I'm going to talk about MIEX as a treatment strategy for highly coloured water. So just in terms of context and background, I'm going to talk a little bit about the treatment works where we installed MIEX in Sheffield. A little bit about its background, a little bit about the challenges it had, why we chose MIEX, and then later on, after Neil and Sasha have done some more detailed look at the MIEX process itself. I'll give you a bit more of an overview of how we've used MIEX in Sheffield, in Yorkshire, sorry. So a lot of today's talk will be about a water treatment works called Langsett. And
So
it's,
sorry, Neil. You just need to press take control so you can move the slides along the top there. There
I
you
do
go.
apologise.
You're fine.
How long have we been doing this for? About 4 years now, and we still can't do it properly, can we? So is that better? I'm on the right slide, Leah?
Yes, you are. Yeah.
Okay, great, right. So as you can see there, there's a map of the sort of Sheffield and Pennine regions. Langsett Water Treatment Works is located to the northwest of Sheffield, and you can probably see the dark brown Pennines to the left and the south of Langsett. That is the problem. So the problem is caused by degrading peat, which gives the raw water colour in the reservoirs around Sheffield a high colour, a high dissolved organic carbon, which is composed of humic and fulvic acids that come from degrading peat. I think you might have had previous presentations from one of my colleagues, Jenny Banks, about why peat degrades and what you can do to stop it. I'm not going to try and do any of that today, but that is the ultimate cause of or the difficulty we face. And in these Pennine areas in Yorkshire, we've probably got some of the most highly coloured water in certainly in the UK. So Langsett's it's a sort of medium-sized works. It treats 55 megalitres a day. It's got typical Pennine treatment of I'm struggling with the technology again, Leah. Sorry, there it is. Look, it's got typical Pennine treatment. We use ferric sulfate for enhanced coagulation. Alum doesn't work as well in these waters. We've got pulsator clarifiers, rapid gravity filters, and manganese contactors. Or we did. That's when we started. So the picture you can see there. Is my pointer working, Leah?
Yes, it is. Yeah.
Okay, it's all right. So this is the main treatment works here. The manganese contactors are here. Got the filters and the clarifiers over here. And the new MIEX, which we've added because I couldn't find a picture of the site without the MIEX, is onto the left here. So the context is very much around the struggle that the existing treatment works had with trying to remove sufficient colour DOC from the water to be able to comply with the disinfection byproduct regulations, principally trihalomethanes, but also to actually be able to physically treat enough water. That the levels of colour in the raw water required prior to MIEX very high levels of coagulant, sort of 20 odd milligrams per litre, and that in itself overloaded the treatment process because it was not designed for such back in the 80s. So turbidity coming off clarifiers, blocking up filters, increased backwash, created a physical throughput problem to actually produce enough water, and we did indeed struggle to meet demand even when the reservoirs are full. So that was the challenge we faced. So we entered into in this case a legally binding contract or agreement with the Drinking Water Inspectorate, which required us to address the formation of THMs by the installation of a MIEX, and that had a regulatory date of the 31st of December 2019, as you can see there. And the following slides, which I think I'm going to hand over now, are about IXOM specifically and the detail around how the MIEX process works.
Hello, everybody. Thank you for joining the presentation today. Neil Woodlands here from IXOM Watercare. So the solution, as nicely put into context there by Neil from Yorkshire Water, will be mainly presented by my colleague Sasha, who is the technical expert on MIEX. But before we look at that overview, just wanted to quickly run through a little bit about IXOM itself, because I'm sure many of you may be not familiar with the company as a whole. It's a company that's globally based. There are different parts of the business across the whole of the planet, but its headquarters is actually in Australia, in Melbourne. We have a head office there, and we actually have a presence in a significant number of countries. It's actually over 70 countries now. IXOM as a company has been around for over 100 years, and actually started its life and its journey in industry and technology through ICI, which is, I guess, a brand name that's much more familiar to people, certainly old school, from back in the day. So it's gone through a number of different branding changes over the time, but IXOM is now a standalone chemical company with offshoots into other areas, which includes IXOM Watercare. Now, IXOM Watercare itself incorporates two major brands. Today we'll be talking about the MIEX brand, which is the ion exchange process. But there is also some product lines in Medora. Now, yeah, if there's of any of interest there, there's obviously some further reading or investigation that can be made. But predominantly, the Medora side is looking at a whole range of different mixing techniques and approaches for improvements to source water, drinking water, and indeed even effluent conditions. But today we're going to be focusing on the MIEX solution, which has been very nicely outlined by Neil, and I'll now hand over to my colleague Sasha.
Okay, so I took control, Neil. Thanks, Neil. Okay, so my name is Sasha Golubic. I'm a business manager for EMEA region for IXOM. A long number of years I've been a technical expert for MIEX, principal process engineer, involved in many of these works, including the ones that we're going to talk about today. And I'm going to be presenting an overview of MIEX as a technology, just as an introduction to the Langsett and Sladen pseudo case study results. So when we talk about MIEX, we talk about two things basically. We talk about MIEX process, but also we talk about MIEX resins. And actually, MIEX resins came first. So MIEX resins is patented suite of ion exchange resins, which we use in MIEX process. And MIEX process is different to all other conventional ion exchange processes because it uses fluidized bed configuration, which we use as a predominantly pre-treatment before other conventional or membrane technologies. So, worth to mention at this stage that MIEX is only proven ion exchange system that is used as a first stage, basically pre-treatment process to other technologies with 80 plus global references. So when we talk about MIEX, we talk about effective, reliable organics removal via using a strong-based anion resins with high affinity to predominantly DOC, dissolved organic carbon, but also some other sort of contaminants which we're going to touch on later on. What's specific about MIEX resins is they're magnetic, and this magnetic ability gives us possibility to make them very small, enhance the DOC removal in that way, and speed up the uptake of the contaminants, while still keeping that magnetic property still allow us to run it in fluidized way without losing these very small particles from the system. Important to say is that all of our resins are obviously NSF and DWI approved, so it can be safely used in drinking water. The second thing we need to know about MIEX process is a simple solution to complex water sources. So fluidized bed process is quite simple. Basically, we use the contactors to flow the raw water through the fluidized MIEX bed, and this is a 24/7 process. Which required no stoppages for regen, because on the other hand, we use off regeneration process, which is basically not in place, so it's off the main process stream. So in that way, we can sort of keep the treatment in our contactors constant, so not running to exhaustion, and we can also and the regen is also done with brine only in most of applications, by 95+% application across the world. So what the results is, and this is just an overview of what we're going to talk about in the next few slides. So because we use it as a pre-treatment, obviously we have, as Neil already mentioned, we have beneficial sort of effect on the downstream processes, including coagulation, chemical consumption, and sludge generation. In many instances we extended the life of GACs, and in some instances extended CIP of membranes to below 90 days guaranteed CIP. Also, as a ultimate result, MIEX process minimizes disinfection byproducts formation in final treated water, and that relates to both total THMs and HAAs. And in many instances we see because of lower DOC content in final treated water pre-chlorination, we see that chlorine dosage for the same residual before and after MIEX is lower. So when we talk about deployment, we would talk about minimal power consumption, because MIEX is really not power intensive. 100% automated treatment and regeneration process. Very modular building blocks, that allow easy scalability, and then full MIEX life cycle too. So MIEX resin products, we have a suite of MIEX resins. Probably what we use in UK and Europe mostly are MIEX DOC, which was the first MIEX resin, and MIEX Gold, which was the second generation MIEX resin. These resins are similar in many ways, and they, predominantly are made to be selective for DOC and color. They remove very effectively bromides, nitrates, and some of the recent research that we did, obviously, PFAS is the big thing of, last few years globally. We started a few researches and shows that MIEX is, quite efficient in removing both PFAS and PFOS, so the species. And also we do some work with also some other local UK utilities, where we use MIEX in a PFAS treatment train process, but not as a primary PFAS removal sort of technology, but as a technology which will sort of remove other impurities like DOC, nitrates, sulfates prior to the other treatment technologies, preventing contamination of other treatment technology and enhancing PFAS removal on them. Yeah. So process background, obviously IXOM is an Australian company, and MIEX was developed by IXOM in conjunction with CSIRO. CSIRO is a government scientific body, and also one of the local Australian utilities, SA Water Corporation, in mid 1990s. It was initially developed as a resin-only product, which will address the future problem of DOC and color removal from raw waters. However, as we found out that that nobody knows how to use this resin, we started to develop technology that we see today. Obviously, as discussed previously, this is what you see on the picture is a small scale sort of MIEX demonstration unit. So obviously, MIEX uses fluidized process, not a fixed bed process, to treat raw water ahead of downstream processes. And we produce, for now, only manufacturing production globally is in Deer Park, which is the western suburb of Melbourne in Australia. And however, significant resin inventories are carried out globally just to enhance the security of supply for the clients. Probably largest storage in UK and Europe area is in Liverpool, where we hold about north of 100,000 liters of each MIEX DOC and MIEX Gold at any point in time, ready and available to be delivered to the clients. So resin properties of the MIEX. When we talk about MIEX resin, we talk about very different when we talk about resins, we talk about very different sort of properties compared to conventional ion exchange resins. So resin beads are much smaller, somewhere between 180 and 230 microns, and we can actually manage that depending of the application we're trying to sort of, raw water we're trying to resolve, versus 500 to 900 microns, which standard, size for conventional ion exchange. You can see that's a lot smaller, and therefore we can provide, 4 or 5 times surface area and improved exchange kinetics. So, for example, this is not stated on this sort of slide, but theoretical empty bed contact time for MIEX resin to remove DOC is 0.5 minutes, basically. So half a minute compared to the standard 15 to 20 minutes for conventional ion exchange. So that's where we make a difference. Also, worth to say at this stage also, because the kinetics are so fast, we don't really design our process around the kinetics. We design about other features, but usually in our high rate contactors, the resident times, empty bed contact time comes down to between 4 and 6 minutes eventually. So that's a real contact time we use in our full scale plants. So as said, we use resins in fluidized beds for the process, and what allows that is the magnetic properties. Also, obviously, if you just run it without, if the resin is not magnetic, and we run it, upflow in a mixed bed, all of the resin will just flow out of the contactor immediately. However, magnetic properties allow resin to sort of create a stable, self-sustained resin bed, fluidized resin bed, which allows raw water to flow through it and gets treated in that way. What's worth mentioning is that patented resin regeneration process results in significantly lower waste volumes, and our waste volumes, are usually anyway depend on regeneration rates, but usually anywhere between 0.05 and 0.15% of the throughput. So we're talking 500 to 1500 liters per meg created, which compared to the conventional ion exchange, we can be anywhere between 2 and 5% is, on a different scale, really. And also, compared to the conventional ion exchange, MIEX resin is actually quite robust when it comes to oxidants, turbidity, and heavy metals. So when we talk about oxidants, so many or some treatment works, they use oxidants as a first stage of treatment, basically prior to everything else, like permanganate or chlorine dioxide. We had some experience with that, and MIEX resins are quite resilient to that, and we can sustain the free dose, residual dose of up to 1.5 ppm of oxidants before we see any influence on MIEX resins. And about turbidity, our stated turbidity maximum is about 100, but if it's a suspended solids which will not settle in the contactor, we feel quite confident that up to 200 is not an issue. So when we talk about magnetic ability of MIEX resin, we talk about on the left you see the you see the time-lapse pictures of the non-magnetized resins, and then on the right is the MIEX DOC resin, basically. So what you can see is that after 1 minute of settling, if you use the same size of resin, non-magnetized resin will not settle at all compared to the fully settled MIEX resin. And this feature is basically what allows us to run it in fully fluidized process with a stable, with a stable resin, self-sustained resin bed. Okay, and the next one. So just wanted to present you a typical MIEX process flow diagram. When we talk about MIEX process flow diagram, we basically talk about two separate plants almost, which work together. You have a contactor, what we call a high rate contactor. That's just the contacting vessel, which allows the contact between raw water and resin, and treats water. So what we have happening there, raw water goes into the bottom of contactor, goes up through the vessel, gets in contact with the brown thing, which is suspended fluidized resin bed, gets treated, flows through the series of lamella plates. Lamella plates are there just to enhance resin and water separation, and goes into the set of troughs on the top, and out into the treated water. Isn't simple than that. On a smaller scale, contactors up to probably 4 mLD per contactor. We build them like FRP vessels. And when we use FRP vessels, we tend to use a pump around system, basically to enhance the fluidization on different flows. If we, for example, for Langsett, which is a large scale contactor, which was about 30 mLD per contactor, we used a series of mixers, top mounted mixers, in order to enhance the resin water, so the contact and resin distribution across the contactor. So basically, the mixers are the only moving machinery within the contactor. So you can see it's a very simple and effective solution. Everything else you see is basically created to regenerate resin of the mainstream. So what we do, we take small portions of resin, we send it into our regeneration vessels. We regenerate with brine and saturated brine. In the process, we create some base brine, and then as needed, we sort of dose back the fresh resin into the contactor. So all of this is done in fairly simultaneous way. This offtake of loaded resin and return of fresh resin. And this allows us to keep our treatment in the contactor very stable in terms of what we need to do in terms of DOC, color, and other contamination removal. So what you see here is a typical picture of one of our large-scale contactors. These are actually quite similar to what was built at Langsett. So you can see, so this is a raw water inlet going through the series of very crude raw water distributor pipes. Raw water is distributed evenly across the surface area of the contactor in order to ensure the proper treatment and proper contact with resin. You can see top protruding mixer, and in this particular situation, we had 9 small mixers enhancing contact. You can see pre-built cartridges, basically of stainless steel lamella plates, and then with integrated troughs. So as that said previously, this is very different to fixed bed ion exchange columns. We can which works to exhaustion basically, which can progressively load up, and then as you lose your treatment, you need to sort of regenerate, switch to next one. So you have quite what we call a sawtoothing in your treatment. With MIEX and this kind of design, you get fairly continuous and very stable treatment results for your downstream plant, which is quite important for utilities. So why are we focusing on pre-treatment? So that throughout the years we tried, MIEX in front and after as a polishing step midway through, but what we found out that where MIEX shines is in front of other technologies, whether it be conventional GSC or membrane. Why is that? Because by removing DOC, bromide, nitrates, and other sort of contaminants, ions ahead of the, say, coagulation, we see significant reduction in, chemical consumption on coagulation or CIP chemicals for membranes, which significantly offset so the MIEX OPEX, compared to them. This is because coagulants carry a positive charge, and they act as a, the repulsive negative charge naturally carried by most particles in water and some soluble molecules. So by removing these difficult to remove fractions from the water, we enhance coagulation. Obviously, we're going to reduce the coagulation chemical consumption, obviously, because coagulation will not be forced to deal with the stuff it's not naturally designed to deal with, but also this improves the coagulation results in terms of flux stability and flux settling rates. And this is the next slide. Actually, this is one of the early or first Yorkshire Water plants which were built for Langsett Water Treatment Works in Halifax, and these results sort of created as initial study in the internal Yorkshire Water study on sort of how MIEX affected their treatment. So what happened? You can see at the top picture, you have two sort of compared sort of jar trials, coagulation jar trials, and on the left you have just 15 milligrams, just a standard 15 milligrams per liter ferric dose on raw water, and then this is the flux created on the MIEX plus half dosage, half of ferric, 7 and 5 milligrams per liter, MIEX treated water plus half dosage. So you can see the flux created are much larger, much more stable, and much, obviously going to have a larger settling rate, which will help with turbidity coming off sort of coagulation stage. And graph below sort of reflects that. So you can see the black dots are just raw water plus ferric results, and the gray dots are the MIEX plus half of ferric results. So you can see the settling rate of the flux is much higher, than with MIEX treatable water plus ferric. So it shows very, very beneficial effect on coagulation, in general. But ultimately, what we found out, and this is again study from Albert. This is ultimate results of the works, which is disinfection byproducts, so the total THM, so the results in final treated water. So the black dots are showing sort of prior to MIEX, so the distribution of THM, so the results compared to the mean temperature of raw water. So what they found at Albert, as the mean temperature rises, obviously the total THM production rises too. So you can see that's a very scattered sort of graph of some high and some low, but basically uncontrolled, or difficult to control sort of results. And then red dots represent sort of the average sort of MIEX, of total THM results post MIEX installation on the same site. So you can see basically what MIEX does is basically create an even play field for the rest of the plant, while ensuring the basically stable total THM, so the minimal production in final treated water, no matter what the raw water conditions are. And this is the ultimate result of which MIEX sort of gives to the process. And the next one will be the last. Okay, so basically just to summarize, what MIEX, we usually install MIEX in front of other potential, technologies, could be whatever, conventional sedimentation, inclined plate settlers, coagulation, depths, which we have, few plants with Yorkshire Water. So, as said, MIEX is at its most effective as a first treatment process in the train, because it's going to give some reduced coagulant demand, reduce sludge volumes, and better turbidity of the coagulation in general, which in turn, as Neil sort of mentioned in his first couple of slides, will sort of reduce solids loading on the filters and can sort of extend time between backflushes, which is pretty much a rule we see across all all conventional sort of upgrade sites. And then ultimately, on many sites with this reduced chlorine demand, because DOC and organics level in final treated water are reducing to much lower levels compared to previous. So the free chlorine sort of consumption for is much less compared to non-MIEX plant, compared to MIEX plant. Okay, now I'm going to turn back to Neil. He's going to talk to us about other couple of plants that we built for Yorkshire Water and the results we achieved.
Great, thanks, Sasha. Okay, so I've just got a few more slides on the experience that Yorkshire Water have had with MIEX over the past 15 years, I guess. So we've got 5 plants in total.
Neil, sorry to interrupt. Just take control because I see you didn't.
I haven't actually moved the slide yet, so it doesn't matter. But I have taken control now. Thank you. So, yeah, so I'm just going to present some data for 3 of the areas that Sasha has talked about. So, evidence of increased throughput at Langsett Water Treatment Works, evidence of reduced ferric dose rates at Sladen Valley Water Treatment Works, which is our latest MIEX installation, and some evidence of THM reduction at Langsett as well. So as I said, we've got 5 sites that use MIEX, all on the inlet to the treatment works, as Sasha has said. So before coagulation, all of these sites use ferric sulfate as their coagulant, and you can see that by and large they're all located on the west of the county, close to the Pennine moorland sources. Variety of sizes. Typically, we've gone for the medium-sized treatment works in the past, around about 40 to 50 megs, 60 megs even at Graincliffe. But the most recent site that we've installed MIEX at is at Sladen Valley in Keighley, and that's it's the actual design of the total works is 12 megs, but the MIEX that we've installed is 3/4 of that at 8 megs. So why MIEX? Well, I think as we've started to already tell you, the Pennines are highly coloured, or give water that's highly coloured. Hazen values of in excess of 300 are not unusual. These Pennine plants were mostly designed in the mid-90s, and using Sladen Valley as an example, it was designed for a Hazen value of about 50 and typically gets 250 during the autumn flush, which is when we see the higher colour concentrations after the summer. So we've installed it mostly for regulatory purposes, for disinfection byproduct compliance, and for each of these 5 installations we've had a regulatory notice with the Drinking Water Inspectorate with a compliance date, and that is for THM. But the added benefit that we have seen very clearly on at these sites is that the MIEX gives or allows the plant to produce more water, and that, as myself and Sasha have already said, is predominantly due to the lower coagulant doses that have to be used, because the MIEX will typically take out 20-30% ish of the DOC, resulting in a lower coagulant dose. So if we look at disinfection byproducts, first of all, this is just some data from Langsett. You can see there that a clear shift in the peaks of THMs that we would see typically during the back end of the summer, following the installation of MIEX in 2020 at Langsett. And that's also reflected, although not regulatory parameters yet. It's been promised for a long time, but the HAAs are not yet regulatory determinants in the UK. But the MIEX has had a similar effect post introduction on the treated water at Langsett, as you can see by the purple dots on the slide there. Sladen Valley now, which is the smaller site in Keighley. This is the evidence. We've struggled, actually, to be brutally honest. I think the theory is correct that MIEX reduces the need for ferric, but some of our online data hasn't been that easy to get, which is why I've had to use the Sladen Valley example rather than Langsett. But you can see from the slide there that post introduction of MIEX, there has been a downward shift of between 15–18% of coagulant used. So that obviously has benefits in terms of operational costs and also the throughput, which I think is my penultimate slide here. So going back to Langsett now, Langsett is designed to do nearly 60 megalitres a day, and prior to the installation of the MIEX, it struggled desperately. And I can remember sitting in various emergency meetings, trying to work out where we're going to get sufficient treated water from at times when reservoirs are full, but they're full of highly coloured water, and we couldn't literally produce the amount of and meet the demand that's required. As you can quite clearly see now, we can ramp Langsett back up to its design capacity, and as a consequence, the management of water in Sheffield has eased as a consequence. So just to finish off, just to reiterate, really, throughput has been improved, particularly during that autumnal period. DAF and clarifiability have improved as a consequence of the lower coagulant demands. Sasha talked about the lower solids loading in RGFs, and we have seen that a reduction in backwash frequency, particularly at Sladen Valley, and that has in turn allowed us to return the supernatant consistently back to the head of the works, where normally during a high colour period in the autumn we would have been unable to do that prior to MIEX, and all the supernatant had to be discharged to sewer, which was obviously a loss of water and not particularly efficient. And finally DBP formation, which we discussed. So I think that's me done, and hand back over to Neil, is it?
Yes. Thank you, Neil. That's a really nice representation of the work that's been happening with Yorkshire Water. So just to sort of wrap this first session of this first hour up of this presentation, just to really go through a summary of what's been discussed previously technically and through the case study information or the Yorkshire Water experiences. Requirements for MIEX. Now, MIEX isn't for everybody. Neil's touched on the fact that one of the predominant problems or issues for the sites that have been taken MIEX as a process is due to the high coloration of water. That's not always the only reason why there would be a take up of MIEX. There are other applications for MIEX as well around DOC and nitrates and sulfates and etc. So there may be challenges in water quality that need to be addressed that other technologies maybe haven't been able to undertake. So what we would always say to people in early discussions is, let's determine whether or not MIEX may be a solution. It isn't going to work for every application. So we would normally undertake a series of jar tests, and this could be taken by the water company themselves in their own laboratories, or send samples over to our labs within IXOM, or we could do it as a joint approach, whichever would be most beneficial. So that would be the way we would make the early evaluation of whether the technology would be applicable. And then, if you like, we could take on a proof of concept. We have an opportunity to do a small pilot unit on a site. We can take the pilot unit to the site and put it in as a test bed, as a trial process. We have these, we have done these in many locations globally. We have a couple of them in the UK at the moment. And the great thing with this is that while consideration for further development of MIEX as a process improvement is being designed or considered, and then further design. And this information is benchmarking and giving some early determinations of where to move forward with the actual process. Now, pilot units are very simple, very much like the main units. You need obviously electrical supply to power the unit. We need a source water. What water is it that we're actually going to be testing and trying to improve? A service water for dilutions and washdowns, that type of thing. A drain, whether that can be directly into an effluent drain or whether that goes into a container for disposal, and some regeneration salt, standard sodium chloride. So it's a very simple process. And with MIEX, we are not a company that will just turn up and say thank you. We've got the technology on board. This is a partnership that we are very much involved with Yorkshire Water and other customers that we work with. Neil alluded to the fact we've been working together for 15 years. That's a big collaboration. Lots of learnings together, lots of things that we've challenged each other, but also lots of good things have come from this. And IXOM Watercare will be part of the design, part of the construction support, certainly the commissioning and the optimization, and we have a full service support package. And although this is an innovations forum, and it might be kind of in some people's minds, well, MIEX has been around for many years. How can this be an innovation? It's because MIEX isn't just used for one particular process. There are new and interesting and yet to be discovered applications for MIEX that we see that we can approach and work with people collaboratively. So why pre-treatment? I don't really want to go through too much of this. This is very much an overview of what's been talked about and wrapped up with in the last slide from Neil there as well. But it's worth just sort of summarising very quickly. We can improve water quality by reducing the disinfection byproducts, haloacetic acids and trihalomethanes. These have a knock-on effect for water quality improvement further down the line. Removing the low to mid molecular weight organics. Now it's important that there's a specific range of organics that can be removed by this process, and again this is part of how we would evaluate the best and optimum use of the MIEX for any particular application. Reducing the negative charge. We've talked quite extensively before about the reduction of chemical usage, and also because there's less solids, there's less filtration, there's less, there's still the same amount of filtration, but there's less amount of backwashes and programs to do that. It's a more efficient process, and there's higher works throughput from that. So we can look at capex savings, and this can be many factors. I mean, there's one or two ideas here. I mean, if you have a particular plant that is in a location, you can't expand the plant, you can't build more plant around it to cope with any kind of source water issues or increasing consumer demand. If you have a new town being built and it's you know, there's further developments of population or industry, this can help with the process of making that plant work more efficiently. It does have a smaller footprint and it has more efficient engineering than alternative pre-treatment solutions, which have been discussed previously. And from a point of view of CapEx, it is looking at, you only need to build the one plant. You don't need to build several duplicate plants so that you have duty standby regeneration, which you would have in typical ion exchange processes elsewhere. And OPEX savings, again, these will be variable depending on the quality of the source water, potential blending of waters, all these sort of things. But in general, we can accept that there would always be a reduction in coagulation chemicals and the residuals thereof. Increased the filter efficiency is increased, and that could also include any membranes. No downtime and making it operationally more efficient, so it's less of a challenge for operators to manage the process because it's being basically automatically the continuous process of regeneration means that there is very little actual operational input to be taken on board. So the MIEX process is in over 70 locations globally, and all of these have different specific challenges. There's different water colour, which we've seen in Yorkshire. We have different contaminant issues in different parts of the world, and there's lots of different examples of case studies that we can provide if there's any interest to evaluate those as to where MIEX would be best employed. A lot of available resources. There's a link here to the website, etc. Yeah, don't want to go on too much there, but again, if you want any more information, there's plenty there on the website, or through direct contact with myself or Sasha, or indeed Neil Whitehead from Yorkshire. And I believe it's now time for a break. I think we've just about hit that right.
Thanks, Neil, and thanks to all the presenters so far for such a great overview of the technology. We've had some really good engagement in the chat so far, so make sure you don't drop off during the break because we're in for a really good Q&A session, and do keep putting in your questions if you think of any in the break and throughout the Q&A session as well. So after the break, we'll be hearing about we'll be doing a deeper dive into the learnings and challenges from the project, hearing about what was trialled that didn't necessarily work, what went really well, and any challenges that they faced and how they overcame them as a team. So make sure you stay on for that because it'll be really valuable. And then, as I say, we'll be followed by the Q&A, and we have lots of great questions in the chat today. So make sure you don't miss out. So saying that, we are now at 10:59, and we have a 15-minute break. So we will be coming back. I'll round up to 11, and we'll be coming back at 11:15. So I'll see you all at 11:15. Just pop. Your cameras and mics are already off, so you don't need to leave the call or anything. Just go and get yourselves a drink or whatever you want to do. Thanks, everyone. Okay, welcome back, everybody. So as I said before the break, we are now going to be going into some lessons learned and challenges overcome. So if I could have all the speakers pop their cameras and mics on for this one, please. Fabulous, thank you guys. And would you like me to control the slides for this section, or do you want to control them, Neil?
No, you can control them, please.
Yeah, no problem. Okay, cool, so off we go.
Excuse me.
Sasha, are you there? Sasha, are you there? Sorry. You could
Sure.
just put your camera and mic on. Thank you. Cool.
Yeah, so what we have here is a couple of slides that we've put together, really to give a kind of a yin and a yang, if you like, or a good and a bad of how things work. Now, I think it's fair to say in all processes and engineering that things don't always go exactly as planned. It's how we overcome challenges and make those resolutions of any of these particular issues. And it's worth then, I think, sharing these with people to avoid duplication of difficulties or errors, so that processes, as in the spirit of spring innovation, is to avoid replication of mistakes or of trialing difficulties. So we have a few examples here which we've put together, and perhaps we can just go through those in a bit more detail. This is not an area of expertise that I have, but if I introduce them, then I think Sasha and Neil will probably be able to put more flesh to the bone, so to speak. So there was, I think, as an example, a pH instrument issue downstream of the MIEX process on one of the applications.
You want to go through that, Neil, or should I?
You please, Sash.
Yeah, it's not well, instrument. It's really, a joint issue between MIEX and what was already installed. I guess at Langsett plant is really proved out to be, on a smaller floors there was no issues really, but then when we got to the close to the maximum flow, there was a bit of an issue with pH changing downstream of MIEX apparently, occasionally. And working together with, I guess, Yorkshire Water technical team, Rob Gothard and other people, who kindly did all the investigation on site. We found out that actually is due to the pH, so the control was difficult because the pH instrument was basically falsely reading different pH when we return regenerant to our process, due to the subtle increase in chlorides. So we resolved that eventually by basically optimizing how we do our regeneration, and in order to try to leak less chloride back in the process. So that seems to do the job. Now that was one of the things, because although the results were quite good, the operations were worried because, on a pH dosing instrument, so the trend, you should really see a flat line most of the time. And it was quite a sawtoothing every regeneration MIEX returns. So that was one of the things that we resolved there. I think it was more of a question of, yes, we leak some chlorides, but that's well known. And, Yorkshire Water knows this, based on the previous projects we did, but I think it was more of an issue with the type of the pH transmitter downstream, but we resolved it, by adjusting the process. The second one, do you want me to continue, Neil, or you're gonna?
No. I think that this was mostly your session, really, Sash, to be honest.
Sorry?
I think this is mostly your session. You mean?
Yeah, Neil? No. I'm asking Neil Woodlands. Yeah. Sorry.
All right. Okay. Sorry.
Yeah.
Always that confusion was going to happen, wasn't it, at some stage? Yes. Yeah. Carry on, please, Sasha. Yeah.
Okay. So the second and third thing, which was found during commissioning, we had extensive problems with one of the very specific instruments we use in our regen tanks, which is quite specific because it can differentiate. It can read both liquid and solid level. It's a guided radar instrument from a specific supplier that we sort of tend to use in every application globally. And this was the first commissioning where we had heaps of issue with it. And for a little while during commissioning, we're trying to resolve and understand what's happening. And obviously instrument techs were coming to site, and us as an experts of how the instrument should work, trying to resolve it, and without success until we realized it's an installation issue basically. So what happened? The guided radar rod was installed on the walkway basically, and the controller were installed off the walkway above the regen tanks, and but in order to make guided, the controller more accessible for operations and control, I guess, the guided radar rod was basically installed through the walkway steel grating, and it turned out that causes huge interference for the instrument, and sort of we resolved that issue during commissioning, basically by changing position of the level instrumentation and ensuring that the guided radar rods are unobstructed. And since then there was I think in 6 years there was no alarm on these instruments, so it was a good resolution. And the third one, the region underground pumps materials. What we did, we used standard pump material for chemical, because we use brine. We tend to use sort of centoprene for these pumps internals, moving parts like diaphragms and diaphragms mainly. But during commissioning, even after a couple of weeks of commissioning, we found out that the centoprene diaphragms blew, and then next one that we replaced. So had a few issues over a month or so with them, and then basically realized that this particular centoprene diaphragms are not suited for some of the positive pressure they see, basically, because when we backflush our regen tanks, these pumps can actually see some positive water pressure, and that is, it turns out that was the thing that was destroying them. So basically what we did, we sort of rehauled all the pump change, all the internal materials from centoprene to EDPN. And, since then, again, that worked beautifully. So, yeah. That was it, Neil Woodlands.
Thank you. Yeah. So, Leah, if you could move to the next slide then, please. So, some things, didn't go quite to plan, but we found ways of overcoming them. Other things, there were some good lessons there that we did overcome, or that we already know that we can overcome just through our own design and some of the additional work that we do through our own process development and research. And these are some examples here. I think it might be fair to say, hopefully, Neil, you could take over the conversation about Sladen Valley, because I know that was quite a particular challenge for Yorkshire Water.
Yeah. Oh, hang on a minute. I'm not sure it was anything to do with IXOM per se.
No.
We'd originally planned to build a 12 megalitre MIEX in separate building. It's not in a national park, the area, but it's planning permissions are sensitive, so we'd costed up for a stone building to match the existing building, and we then had the idea that if we reduced the volume of the MIEX of its maximum treatment to 8 megalitres for a 12 megalitre plant, we calculated that we could achieve the desired THM reduction at the same time as fitting most of it inside the existing building. And I wish I hadn't made that decision 4 years ago, because it caused our designers a right headache. We had numerous access and lifting and maintenance sessions to try and work out where this stuff would actually fit in. And what they've done is actually fantastic. Kia were the principal contractors who were working with IXOM to get all this in. So it's been a good scheme overall. It's worked well.
Yeah, thanks for that, Neil.
Can I just there's been some questions in the chat about pre-filtration. So we've few of us, Graham Moore, I think, was presumably from Scotland. I think you are, Graham. So at Sladen, IXOM recommended, I think, didn't you? For, I'm not saying wrongly, Sash, but that a 2 mil screening was required due to the smaller pipe bore on an it's much more of a package plant, the Sladen Valley Treatment Works, whereas the other sites we've had before have been sort of bespoke builds with concrete tanks, etc. But the smaller pipe work on the Sladen Valley scheme necessitated the inclusion of some Huber screens at 2 mil diameter, and it cost us quite a bit of money in the end. And to be honest, we've not needed them, but there has been quite a bit of say Graham's been asking a few questions about peat breakthrough and stuff. We've seen a little bit of that at Sladen. Doesn't appear to have impacted the processing in any way. It's not something we've previously observed, although we presume it's happened and it's gone into the DAFs and we've not noticed. So that's our experience of screening. I would, if I was doing it again, I think I would put some more fine mesh nets on taps several months before the work was designed to confirm what the sort of the particulate challenge was going to be.
Yeah, thanks. I mean, again, that's a good lesson for any potential, future developments. It's doing the pre-work before we actually get involved with putting the spade in the ground. Yeah, thanks for that. I see as well, and I'd like to call out here for Jenny in the background as well. I know in the chat that there's been quite a lot of questions have been raised, and Jenny's kindly answered quite a few of them. I haven't got the chat open at the moment, but I know that's been the case. So thanks very much, Jenny, for assisting with those replies, and indeed, if there's anything that we can develop from there, if there's anything that people want to expand on, we can work on that together, I guess. So Sasha, if I hand it back to you to talk about the other areas of lessons learned, things that we've had good examples of in the rest of that slide, please.
Yes. Okay. So I'm on my own. I am. Okay. So I mean, works with gravity flow and pump flow. Like MIEX can be work under gravity or pump flow, no issues. I mean, Langsett works, I think, purely on gravity. Neil, is it? And then some other sites they combine gravity and pump flow.
Neil, sorry, you're just on mute.
Sorry, it's all this swapping and changing. Yeah, Sladen, we had, because of the space constraints, not just because we tried to get it in a separate building, but probably it would have been the case anyway. We have to pump the MIEX treated water back into the main treatment process, the DAF coagulation stream. So not ideal, but it works fine. We've got a big tank, acts as a buffer. No problems with the control. We've had it over a year now. Works okay.
Yep. That was an offset of needing to fit into the building, was it? So yeah.
Yeah, but we could have put it outside. But I still think we might have had some challenges with the head of the reservoir level, Sasha. When,
okay, so
when the reservoir levels gets lower, it's sort of I don't know. It might have been an issue, but
yeah. Okay. The next one is not particularly connected with Yorkshire jobs, I guess. So what we know is, the MIEX remove PFAS to a degree, but what we're now learning with, working with one of our clients is that, MIEX is a great support to other technologies that are to remove PFAS, like GAC. Seems like removing, DOC, especially organics and DOC, some nitrates and some other ions prior to GAC, so they actually can extend the life of GAC significantly, or can mean a difference between using virgin or regenerated GAC, for certain applications, PFAS applications. So it's obviously reflects in OPEX sort of numbers significantly. So if anybody's interested in that, obviously reach out to us and we can talk about it. And then, as Neil, said in his last sort of slide on Sladen, there's actually over the years, and this was started actually first Yorkshire Water plant in Albert, in order to optimize OPEX on the plant, all of the Yorkshire Water plants, Yorkshire Water MIEX plants have possibility to blend between raw and MIEX treated water. Now, so that means that in good periods of the year, you can run MIEX, you can run MIEX lower flow rates and, still have a great organics removal and, good process downstream and blend it with raw water to a certain degree and still have great results in terms of disinfection byproducts, everything else, So that was the one key thing that was used. That knowledge, I think, previous knowledge was used in also with calculations was used, by a Sladen project, which sort of allowed more certainty about building an 8 MLD plant for a 12 MLD sort of overall throughput, if you will, and 8 MLD MIEX plant. So that's one of the learnings, and that's something we try to implement in, most of the new projects we do. So yeah. Okay.
Okay, thanks for that. Yeah, that's some of the lessons learned. I think from where we are now, I think we move into the questions and answers. I don't know how we want to do that. Leah, do you want to take over and discuss that?
Yeah, absolutely. So thank you everybody for the great engagement in the chat. Again, it's great to see so many questions and so much interest. And as Neil said, thank you to Jenny and to Neil Whitehead as well in the background for having answered some of those. I do just want to apologise now. It's quite hard to keep track of because we've got so many messages. So if I do ask any questions that have already been answered or repeat myself in any way, I do apologise for that right now. I'm just going to stop sharing the presentation. I hope everybody's enjoyed the presentation and found it really interesting. I know I have. But I'm just going to stop sharing so that we can see our lovely presenters a little bit better. Okay.
The first time I've ever been called a lovely presenter.
Perfect. Okay, so starting right from the top, a question for Chris from Sasha when you were doing your kind of technical overview. Is PFAS shown to be separated from resin during the normal regeneration process, or does it accumulate?
Yeah, well, it's for our, hi Chris, thanks for the question. For our, we did extensive research with few universities and couple of utilities in US as PFAS. US is on the forefront of introducing PFAS, very strict PFAS limits as a regulation. And we found out a few things. First is, yes, MIEX does remove PFAS. Second is, yes, it's very difficult to regenerate via normal regenerants. By normal regenerant for us, I think brine or bicarb or any kind of non-dangerous sort of regenerant. Third is, yes, you can use some other dangerous chemicals. We're going to regenerate fine, but whether you want to introduce that to your water treatment sites is sort of questionable. And as I said, so that's a summary. Fourth one is what we're doing with one of the UK utilities at the moment. We're using MIEX as a support, basically pre-treatment to the PFAS treatment train, if you will, and making it a lot more efficient. So I think that's what we can sort of talk about now. And then if you want to talk about, which kind of regenerant we would need to use, stuff like that, we can, no issues, it's not a secret, if you will. It removes like 60% methanol, basically. But, it regenerates it just fine. So there is a possibility, but we're still in a, for the MIEX being served as a full PFAS option, if you will, just PFAS specific option, we still need to do some work.
Perfect. Thank you, Sasha. And is that kind of in the next steps for IXOM? Is that kind of where you think you'll go next?
Well, we'll be looking at that extensively because it seems to be a big thing. Yes.
Huge interest at the minute, isn't there, in the industry?
Yeah.
So brilliant. Okay. So next question from Jonathan for you also, Sasha. What effect does the MIEX have? What effect does the MIEX have? No other minerals present in the water. Is it removing alkalinity as well?
We remove a little bit of alkalinity, nothing significant for the downstream processes. Yes.
Perfect.
So that's it basically. We remove some bromide, nitrate, sulfate, A little bit of alkalinity, yes, but as the resin ages, removal of alkalinity is not as gets less and less, basically, almost to a flat line.
Perfect, thank you. And the next question from Nicola, I'll throw open to all of the presenters who have an idea on this. Is the MIEX currently only approved as a treatment option for colour removal rather than PFAS and nitrate?
Well, I can answer the approved bit. It's not approved as far as I know from a regulatory perspective. In the sense, well, it's Reg 31 compliant. But we don't, to my knowledge, the regulator doesn't approve processes in that sense in England. I said England there, Graham, make the same mistake as last time. Our experience in Yorkshire, and I think we are still the only English water company to use MIEX. I know there's been quite a lot of work going on in Scotland, but in England, we only use it as a pre-treatment for raw watercolour for DOC. We don't use it for any of the other applications that have been mentioned.
Perfect. Thank you, Neil. Appreciate it. IXOM, Neil and Sasha, do you have anything you would like to add to that question at all?
No, I think I agree. There's no approved process as such. Yes.
Great. Thank you. Okay, so Sasha, another one for you. How did the wastewater works manage with the additional salt? Did it cause detrimental effects, or is the dilution high enough that it was not noticed?
In my mind, the dilution is because our depending area, obviously, where the sewer is and everything else, I cannot comment, 100%. But in my mind, I didn't realize that Yorkshire Water had many issues with discharging waste brine to sewer, because 4 out of 5 sites discharging to sewer, Neil, are they?
Yeah, no, that's fair comment. I mean, I think initially some of our wastewater colleagues had a little bit of concern, but when we did all the calcs with them, the volumes going into the works were insignificant, really. So, I mean, I think I put on the chat to David Metcalf for the Sladen one, we would discharge about 7 cube per day if the MIEX was running at full tilt. And that goes down to Keithley's main sewage works, Keighley-Marley, which it's all in PE equivalents, isn't it? But I mean, Keighley-Marley's a big sewage works. I don't know, 50,000 equivalent or something like that. More probably. I don't know. So to date, we've not had any problems. If you wanted to send it to a much smaller sewage works, then you'd have to be a bit more careful and do a lot of thinking.
I see. Okay, is that I think you put something in the chat, didn't you, about the size of the waterworks having an impact on the on that question? So yeah, great. Thank you, Neil. Next question from Marie is, what is the brine volume generated by MLD of water treated?
Well, Sasha can give the official version, but my example was 7 meters cubed per day when the MIEX is running at 8 megs full tilt. I think that's right, Sasha, isn't it?
Yeah, but it really depends. Say for Yorkshire Water's difficult sites is about 900 liters per meg, I would say, to 1,000, including Langsett, or less, so, but these are very works which operate at very low regeneration rate, or very high regeneration rate, if you have, we have some other clients elsewhere where we operate at high regeneration rate and we produce a lot less waste, I think these are the high-end examples. Langsett,
worst case.
Yeah.
Great, thank you. Next question from Jonathan, I think also one for you, Sasha, is, given the reduced coagulant demand, what is the cost per MLD compared to conventional coagulant alone?
It's difficult to say, Jonathan. We it's process needs to be looked at the holistic. Like, for example, Neil said that their average reduction on Langsett is probably estimated between 15 and 20%, reduction in coagulant in his slide. But you need to understand that this is on blended water. This is not just 100% MIEX treated. So basically, you have an option to, find your balance, as Yorkshire Water does on all of their plants, between running, full MIEX, which is probably, less efficient OPEX wise, and then get maximum coagulation reduction, or running blend and then a lot of coagulation reduction and, some MIEX OPEX reduction, and all of that accounts to something, but it's difficult to say because it's going to also come down to the quality of the water and what do you call it? Again, regeneration rate, salt consumables like salt, and whether you pay for your waste discharge, stuff like that. So it's really, it's really difficult to estimate that based on no example.
Well, yeah, I'd agree with Sasha. I don't think that the offset in ferric dosing completely compensates for the cost of the MIEX. It doesn't, but it's a benefit of. I mean, the MIEX is put in not as a cost-saving measure; it's put in as a treatment measure. But it does have some benefit in reducing coagulant demand. Yeah.
Great, thank you, Neil. And then one for you actually while you're here, from Stephen. From Yorkshire Water's perspective, has there been any sort of evidence of deterioration in performance over a longer period of operation? Appreciate that might be hard to answer off the top of your head with no data, but
Jenny, are you on the call? Can you've probably got maybe a bit more of a view of that? I
totally fine if you want to kind of go back and we can send an answer to them kind of personally outside of the showcase if it needs kind of looking into.
I mean, we've been having discussions about changing some of the lamellas, haven't we, Sasha, at Graincliffe, and that gives us an opportunity to reduce the amount of resin loss we get, and as a consequence save a reasonable amount of money. So but I'm not sure that's as a consequence of deterioration of the resin particularly.
There was no, but these are rather, Neil, if you agree, these are rather like original installation, product availability issues, because, talking about lamellas, I mean, because on Langsett as the latest, second latest, but, latest really large scale plant for Yorkshire, there are some significant improvements compared to the oldest type plants, which we're now trying to sort of reverse and maybe re-engineer into the old plants and get better results.
Yeah, that's a fair comment. Yeah.
Thank you both. Oh, sorry, I had myself on mute there. Thank you both for the answer to that question. So interesting question from Jenny that I just want to make sure that we don't miss in the 15 minutes we've got left, which is, I have a question for IXOM. Have you looked to develop recycling technologies for the brine waste where a sewer discharge is not possible? And if so, how to control DOC fouling of membranes where the molecular weight and size of the DOC must be so variable over the year?
Yeah, well, we extensively work on that, because that's the second thing really that probably, next thing that we need to sort of resolve is, we can minimize waste, through the proprietary regen. We have add-on process, which can sort of halve the waste further, but, still not a zero liquid discharge as proven, what I mean? So, working with a couple of partners at the moment to try to minimize waste. I think Jenny knows this well. I don't know if I should comment on that. And I think Langsett sort of maybe the plant that's going to see some sort of demonstration plant in near future, because Langsett is obviously one of the Yorkshire Water plants that doesn't have sewer. So currently trucking waste to wastewater facility. But, we have a couple of options. Basically, what we can do, we use very specific vibrating membranes to sort of reject DOC, I guess, and let the salt through. Nanofiltration sort of supply is called VSEP, but it's they're highly resistant to surface membrane fouling, and this seems to help with sort of with bad quality of liquid, like our waste brine, to minimize fouling. So we work with them, and we have a full-scale demonstration facility in our Wanneroo plant in Western Australia, where we sort of minimize amount of waste. They don't have sewer too, and they're 140 MLD facilities, so you can imagine, a fair few trucks of waste brine daily. Where we use this technology to minimize to half basically their waste generation, which translate into a fair bit of OPEX saving for them, and it's used for years successfully. Now, reject or concentrated DOC from the membrane is actually, we early days we found out that it's what we call a very potent, not fertilizer, biograph stimulant, because contains natural species of DOC, humics, fulvics, etc., in the purest form. So many companies, we work with at the moment, they're interested actually in sort of having waste brine as their sort of start, or start of material to produce some kind of biograph stimulant of fertilizer, whatever you want to call them. Now, unfortunately, we're not into market of selling fertilizer, so we cannot actually do that alone. But that's why we partner with different companies to try to do that. We partnered with Borak in Australia. It was an Australian company that actually, the Wanneroo plant I was talking about, they were sort of initially giving, but now they're selling their reject waste brine to Borak to produce some fertilizer. And then in UK specifically, we work on a couple of projects with one of the EU suppliers of wastewater technologies, and they seem that they think that our waste brine is very good for their process. So see what happens. I don't know if that's what you're implying to, Jenny, but I know these guys will be talking to you previously. I think so. Yep.
Great. Thank you, Sasha. Jenny, hopefully that has answered your question for you. Okay, so another question for Graham, again, open to anyone who wants to share thoughts on it. And again, apologies if that's already been answered in the chat. I can't follow along right now. But we know that virgin resin works incredibly well. 80% DOC reduction in coag with new resin is often achievable. But then MIEX performance declines over a period of time. How is that managed when a MIEX plant is first brought online, i.e. is the resin dose increased gradually to allow the coag dose to be managed until MIEX DOC performance plateaus?
That's for me, I assume. Thanks, Graham.
Simple answer was no, but
Well, we didn't actually, in our experience, I don't know if Neil's going to agree with me, in terms of DOC or UVA removal, MIEX process removal usually deteriorates because of the process issue, not the resin issues. Something else happens which we don't control in time, and then we lose treatment, like you lose some resins from the process, some more resin, or you don't top up at the time that it happened, stuff like, or you don't have salt on time and you regenerate without salt, which happened on few sites, so in my mind, because we recuperating, we topping up with small amounts of virgin resin all the time, usually does not happen. But yes, virgin resin basically as supplied for commissioning is obviously 100% clean, so it doesn't have any base loading. So I think if that's what you implied to, Graham, yes. Initially, when we loaded for first probably a week or two on some plants like Langsett, it took a week, maybe not even that, to get that base loading and get to a stable performance. On some cleaner waters is a bit more of a challenge that we need to think through, I guess, because I know at some Scottish plant, which probably Graham is well aware of, a lot cleaner water, probably more DOC, less color. It takes a long while for that to happen, and even at Scottish plants, 3 Scottish plants that we built, first one of them plateaued reasonably quickly, while second and third one sort of somewhat slower. So it's a thing that we need to think about, how to approach the commissioning, because it's a changing nature of of treatment that sort of affects the downstream work. Initially you get 80% removal, you set up your coagulation dose, but then, after a few months, you may sort of change to maybe 60, then you need to reset it. Is that a question, Graham? I don't know if you speak up if you're online.
Thanks, Sasha. I'll check the chat
Yeah.
in a moment and see if he's commented further on that at all.
I sort of got the impression maybe it was the question from Graham was whether the process suffered a shock when the MIEX was introduced. I'm not sure that's correct, but we haven't seen that. We use automatic coagulation control with UB254 monitoring to control the ferric dose or the coagulant dose. So the returned MIEX or the blend of returned MIEX treated water and raw water is then is monitored for UV and the dose moderated accordingly. So
great, thank you, Neil, for that addition. Graham has popped in the chat that you've both answered his question, so that's great. Thank you. Okay, so we might have time for just one more question, as it's kind of a question in multiple parts with comments about the question that add more questions to it. So if you need me to repeat any of this at all, just shout up. But we start with a question, I think, for you, Neil, from Yorkshire Water's perspective again, from Chris, who has asked what level of pre-filtration, screening or other treatment is typically provided upstream of your MIEX installations, and have some raw water sources been more problematic than the others?
Yeah, well, I thought we discussed this partially, that the most intensive screening or the most prescribed screening we've had to put on is at Sladen because of the small diameter pipe work. But we've not seen, I've put in a chat, I would have expected to see a few fish on those Hoover screens, but we've not even seen that. Don't know what it says about the quality of the reservoir, but so I can't recall what the screening requirement is at Langsett and the bigger sites, Sasha.
It was Langsett was 2 to 6 mil Hoover screen, man. It was just a rotating screen, band screen.
Yeah.
I think it's 2 to 6 mil. They don't give you a rating per se. They give you like a range.
Yeah. And Graincliffe's not got any, has it? I don't think so.
Graincliffe, I don't think, because it's very clean. There's no turbidity there at all. So.
Yeah. So most of the reservoirs where we've put these MIEX units on, I've got high colour but very low turbidities typically. So
great, thank you. And again, sorry if it was a bit of a repeat question. It's been difficult to follow along. Okay, great. So the comment from Graham on that question is that it's an interesting question, but it's doubtful that we are comparing like with like on raw water quality. Sorry, go on.
No, I agree. Yeah. I think you've got to take it into, you've got to understand what the nature of your raw water source is, haven't you, and design accordingly. As I said, we probably didn't do enough of that up front, and I think from a capital perspective, if we'd have known that the challenge was hardly anything that we've seen, we probably wouldn't have put the screens in, and I think that would have been a risk decision for Yorkshire Water to take, but that's what we have to do all the time. So
yeah, absolutely. Okay, thank you, Neil. Appreciate your thoughts on that. And then I guess, Neil, from IXOM, do you have any kind of thoughts on Graham saying that he believes that it's kind of the generic pre-filter solution is not the right solution, and it's kind of not a one size fits all for pre-treatment, so it's kind of very IXOM would need to play a role in that, in figuring out what kind of filtering we need on these.
Yeah, I would agree with that. I mean, the whole design stage starts, as I said in some of my slides, about taking an evaluation of the water to be treated, and the variability of the water over seasons, perhaps. It might not just be a snapshot. It's a study. It's not just a snapshot event. It's a process that needs to be taken from a starting point to then evaluate what the best solution will be. And I'm quite open to say that it wouldn't always be that MIEX is the best solution. We've got to be very clear about that. yes, we would like to promote MIEX as best we can, but it's got to be so that it will be of a benefit to the final outcome. So yes, we
Brilliant.
would do a full evaluation of waters in conjunction with the end client.
Great, thank you, Neil. That's a great answer. So we do have a couple more, but I think again they've either been answered in the chat or we've kind of already touched on them. So one from me is just what are the typical kind of timescales that we're looking at for implementation of MIEX? So either as a trial or once it's been trialed, what's the kind of timescale for scaling that up to be kind of part of business as usual?
I think that depends on what type of delivery asset management process you've got, Leah. I don't think that's entirely in the hands of IXOM. We have always procured the services of IXOM. I'm getting out my ground a bit here, but I think you've always worked as a subcontractor for a bigger tier one company. Is that right, Sasha?
Yeah, because we don't, get ourselves involved in civils and other, permits and stuff like that,
So it's, I mean, Sladen Valley, smallish one, you're probably talking 3 years, probably, I would have said, from start to finish.
Great, and that's 3 years from kind of first reaching out to IXOM to implementation.
Was that to date when IXOM was operational, Neil? Because we know
no. That's from the sort of the starting of the project to the final, including all the design elements,
all the back end things. Yeah.
Okay. And I confess that we're not the most efficient delivery company. So there's all that sort of those. You could do it an awful lot quicker.
Great, thank you, Neil.
Just to touch on that a little bit more, that's for a full plant. Obviously, for a trial situation, the trial pilot units, there would be a less period of time. There would be a discussion to get the pilot units manufactured and put into place, and that would be, I'm going to say 6 to 12 months from start to actually placed on site. It would be a reasonable time frame.
Great, thank you, Neil. Okay, I think that takes us to the end of the session. So thank you again to all of the audience for taking time out of your day to be here today, and for such great engagement in the chat. Again, it's always great to see so many good questions, a sign that you found the kind of information shared today really valuable. My colleague is going to be popping in the link to the poll again. If you could just take a moment before you leave to let us know how you found today, and whether you plan to make use of this knowledge shared today at all. She's also just popped in some contact details for our presenters today. So if you do have any further questions or you are really interested in IXOM, feel free to reach out to either of the Neils and find out more. And just to say, we will be posting this recording of today's event on our platform alongside a written case study within the next approximately a week, and we will post on our LinkedIn once that is available on our platform. So if you're not already, give us a follow on LinkedIn just so you can see when the case study from today is going to be available. I think that is everything. Thank you again to the presenters for all of your hard work on this. I appreciate things are really busy at the moment, so I really appreciate you taking the time to put this presentation together and join us today for a really informative session. And I really appreciate the openness and honesty with which you shared the learnings from this project. So yeah, thank you everybody, and thanks again to the audience, and I hope you all have a lovely rest of your day. Thanks everyone.
Thank you very much.
Thank you very much.